In our last video, I showed you how to make a simple indicator solution. Now I'm going to kind of show you how it works. You have your nice purple cabbage solution in each of these cups, and it's going to change color in response to whether something is an acid or a base. Now, with any good science, you need to ask yourself a question. That is the purpose or object of your lab. So I'm going to put a P for purpose. And in this case, I'm going to say, what changes the color of our indicator? So, what changes the color of our indicator? And then each of you will make your own hypothesis. A hypothesis is an educated guess. Based on what you know, what do you think changes its color? I know a little bit, so I'm going to say it changes color due to acidity. So, acidity changes its color. It's not a complete answer. Obviously, basicity also changes its color, but this is my hypothesis. My method and materials are test solutions, and then I also have my indicator solution, which is our highly technical cabbage water that we made in our last video. And then we're just going to go ahead and pour a small sample of a test solution into indicator, and obviously we'll observe our results. And then we have results. We'll see what happens. We can make ourselves a little chart if we want. We've got Coke, vinegar, toilet cleaner, ammonia, lemon juice, and baking soda. And then under each of these, we will indicate the color that it turns. A little bit about, well, I'll hold that thought for now. Let's just get on with the science. First of all, we'll start with each of you can make a guess out of each of these what color you think it's going to turn. If I pour a little bit of Coke into my indicator solution, what color do you think it's going to turn? Now I'm going to do that. Obviously, some of the color of the Coke will affect the color. But if you notice, it kind of turned a pinkish color. Can you see that? Kind of a pinkish color. Okay. And I love Coke. Don't try this at home unless you know it's something safe to drink. Okay, here we have vinegar. So what color do you think the vinegar is going to change? If Coke changed that color, I wonder what color vinegar is going to change. Pour a little bit of vinegar in. And we get a nice bright pink. That should give us a little bit of clue as to what turns it pink. Here we have the Works, just a toilet bowl cleaner. Basic just means it's brand, it's not super, it's not deluxe, it's just basic. I'll put this in. It's a little bit of a bluish color to start with, but let's see what color. You can buy this clear, but I don't have access to stores right now, so we're just going to use this one. And if you'll notice, it's also turning it kind of a pinkish color. See that? I'll leave that there because that will actually change the color of my tablecloth, and I don't want that to happen. Here we have ammonia. Don't get too close to this. Don't smell it too close. It'll burn the inside of your nostrils. Doesn't feel good. In fact, my sister did that when we were younger. She wanted us to test something for cleaning. It was a clear solution. So she inhaled it. Bad idea. Never smell or taste something you don't know what it is. She barked the inside of her nasal passages. It was not pretty. All right, here we go. Ooh, don't tell her I said that. You'll notice it's a totally different color. You see, it's a very green, a bright green color. Should give you a clue that it's going to be different from the vinegar. Ooh, that's very potent smell. Now, lemon juice. I wonder what lemon juice is going to do. I'll put lemon juice in here. I get a nice pink color. I wonder if that's what pink lemonade is. It wouldn't taste good. It's cabbage water that has turned bright pink. And our last little indicator here, little test sample, is our baking soda. We're going to put some baking soda in and see what color that turns. You'll notice it's turning blue. Kind of a bluish color. We have kind of a ranging rainbow. That's what an indicator solution does for us. It gives us a general idea of acids and bases based on the color that it changes in response. Coke went pink. Woohoo! Vinegar was bright pink. Woohoo! The toilet bowl cleaner that had a little bit of a bluish color to it, so we have to kind of ignore that. If you had clear toilet cleaner, it would actually be a lot clearer of a pink color for you. Woohoo! The ammonia went green. Woohoo! Lemon juice is again a hot pink color. Woohoo! And baking soda is a bluish green color. Woohoo! So, conclusion. Acidity changes its color. Well, it's not just acidity that changes its color. We need to answer the question, what changes the color of our indicator? Acidic and basic solutions change the color. So, I don't have a lot of room, but we would write a concluding sentence to say acidic and basic solutions change the color of our indicator. And that would actually be a real neat, small little lab report that you could write up. Put a title on top and your name. Write this out just like this: purpose, hypothesis, method and materials, results, conclusion. And that, my friend, is a well done lab. Now, for just a moment, I want to discuss the pH scale. pH scale has to do with the hydrogen ion, and it tells us whether something is acidic or basic. We know that in most cases, acids donate protons, and bases accept protons. So we have a pH scale. It goes from 0 to 14, and in the middle we have what we call neutral. Neutral means it's neither acidic nor basic. Over here at 14 we have our extremely basic materials, and over here we have acidic, strong acids. As we get this direction, our acid strength increases. As we go in this direction, our basic strength increases. So if we're to look at this variety, we could say that somewhere between vinegar and lemon juice are probably some of our strongest acids on the table. But these, we have lemon juice and vinegar and Coke and toilet cleaner. It's all over here. It's not so acidic that it's going to burn you, because obviously we drink lemon juice. Too much lemon juice might cause sores on our tongue, but it's not going to be super acidic like battery acid. Now that'll burn you, and that would be over in this extremely zero type of caustic acids. But really, lemon juice and vinegar is kind of over here. It's acidic, but it's not going to hurt you. Bases, we have ammonia is our most, it's green. And then we have baking soda here in the bluish kind of coloring. And if we actually balanced our acidities really well, then we would actually have a clear color. And here we've got kind of a purple color, and here it goes more and more pink, more and more bright pink. And here we go, you know, pinkish purple, bluish purple, green, or bluish purple, bluish greenish, and then green. And your extremely basic things are also going to be extremely dangerous and things that will burn you as well. But as you get more and more to the center, we get more into our everyday working materials. And that is how you use an indicator solution.
Congratulations!